Record ni untuk orang yang tak join ni.
Sebab kadang dia ada limit for 100.
Oh, I see.
Macam Google Meet.
Sialah.
Dan jawab C.
Yang jawab C. Yeah, the answer is given as B because actually sepatutnya dia tak adalah short sangat because all filaments sebenarnya dia nak heat kan. So dia kena heat baru dia jadi bright. But then Y has higher resistance. Jadi bila Y has higher resistance compared to X, then kita dapat power equals to VI or I equals to V over R. So write down P equals to V squared over R. Power P equals to V kuasa 2 divide by R. So as resistance increases, power will become what? Sebab ni over R kan, so power decreases.
As R decreases,
as R increases, resistance increases, power decreases. So that's why brighter should be the one with the lower resistance, bukan higher resistance.
so brightness dia is affected by the power.
Power, brightness is directly proportional to power ataupun energy lah. Energy kan power about the same kan. Power, energy is power times time, isn't it? So brightness is equals to power. So the greater the power, macam 100 watt. 100 watt is brighter than 60 watt misalnya or 20 watts. So what makes the bulb to different in terms of power? They just change the resistance. So higher resistance means lower power. Lower resistance means higher power. So answer is
ramai tanya, bukan usually for filament we really like higher resistance sebab higher resistance lah.
Betul. Ya, betul. That's why soalan ni actually pelik juga sebabnya filament dia tak adalah, memanglah first dia nak heat dulu. Dia nak heat. Memang dia nak heat barulah dia produce light kan. Tapi dia difference dia sikit je dari segi mungkin dia punya ketebalan tu, dia punya nipis tu just berbeza sikit je. So it should be about length dia pun patutnya samalah. But if not, memanglah sebenarnya kalau macam ni X memang tak bright, kalau dia pendek memang is not bright lah. But then when you calculate the terms of power, why 100 watt is brighter than 60 watts. So what they change is just the resistance tu. I would also, kalau kita bagi suggestion kan, kalau kita nak something for heating, memang kita akan suggest the one with the one with higher resistance. But when we compare about brightness of bulb, you must understand the formula ni. P equals to V squared over R. So the higher the resistance, the lower the power.
Tapi the theory is that memang betul lah we need secara kalau common sense, bukan common sense lah. Maknanya sebelum ni kita ajar
nak heat
we nak heat.
Higher resistance.
That is true lah, betul.
Orang ni bukan orang yang kejar malam ni. Jin ke apa mah? Dia macam pemburu senyap ni mah. Pemburu senyap.
So kita nak higher heat lah.
Kita nak higher heat to build a bulb. Tapi in terms of kalau nak compare power, we need to find the one with the lower resistance has higher power.
Okey, dah tanya tak, kalau soalan essay keluar kan, kita nak ambil yang mana?
Kita kalau soalan essay tu dia nak build something for heating, kan? Then kita kena ambil yang memang nak high resistance.
So
kita nak ambil, of course nak high resistance. Tapi kalau kita nak dari segi Ya, memanglah kalau lamp X ni kalau dia kata dia sebenarnya thick and short ni is actually dia thin juga. Cuma mungkin yang Y ni thinner than this X. Sikit je. Because Y memang bila Y ni compare dua-dua bulk, that means memang Y ni have higher resistance daripada lamp X. So sebab itulah power dia lamp Y is less than lamp X.
I see. So ni sebab figuratively lah kan, sebab dia tak bagi tahu.
Bila dia buat comparison the same bulk, tapi kalau kita nak build something for heating, kita nak heat tu, kita nak kumpul heat means we must have higher resistance.
Lah.
Yep.
So soalan ni sebenarnya it's not a very good
soalan
question.
ni actually drawing dia ni terlalu
bagus.
It's not a good question because dia compare compare dia lain sikit lah.
Dia tak bagi values Kalau bagi figure mungkin okay sikit. Okay, so it's not a very good question lah.
Yeah, it's not a very good question.
Okay, tak apa.
Memang boleh argue kat situ.
So, maksudnya kalau nak high resistance ambil thick. Kalau nak brighter ambil thin. Betul ke conclusion tu, Liza?
Kalau nak brighter, kalau kita compare between two bulbs, brighter means the one with the lower resistance.
Which is this one lah.
Yeah. Tapi kalau kita nak dari segi heating, kita nak choose something yang higher resistance.
Kalau nak buat heater rumah ke apa?
Heater, yes, higher resistance. Tapi memang mana ada bulb yang guna thick ataupun short unless memang kita nak nampak filament saja kan, macam that carbon lamp kan, dia orang pernah buat eksperimen kan, yang memang kita nak ambil filament, then we will choose something like that yang kita nampak bright tu cuma the filament, not giving the brightness, the light.
We just want the heat to be produced.
Yes.
Okay. Right. Okay, next one. Pasal pasal emitter voltmeter. What is the answer?
The answer?
I1, I2. Jawab C.
Okay, good. C is correct. Okay, same current flow because the I1, I2 is the same. Voltmeter 2 volt because they are parallel, betul?
Kalau voltage across is always the same 2, 2, 2. Okay, EMF.
Okay, EMF.
Electromotive force equals to its terminal potential difference.
What's your answer?
Jawab C. No current flow in battery.
Good, good. Okay. So when I is 0, then only the terminal potential difference will read the reading of the electromotive force. Right. Terminal potential difference ni maknanya voltmeter across the dry cell. Betul lah. The terminals. So betul, C is correct.
Okay, 40. What type of output? Diorang jawab AC.
Okay, good. Because these are slip rings. Good.
Kalau pakai commutator is DC. Beza je lah. That's the only difference.
Dia bukan split ring, ni slip ring. Itulah. Itu bezanya kalau commutator or split ring, baru DC.
And
okay, good.
Also we don't have a battery lah. Satu lagi approve generator dia pakai crank. Maknanya kita buat manually lah.
Kita kena mechanical energy change to electrical energy.
Okay, 41, electrical transmission. Why they raise commutator DC? Yep. Why they raise 25 kilo to 132 kilovolt? Why? Jangan cakap C, to reduce the energy loss during transmission.
Okay, good. Betul. Because
Dia pun sama.
kita nak reduce the current.
Students pun selalu confused. Bukan kalau sebab diorang ingat electrical transmission ni obey Ohm's law.
Oh no, sebab ini transformer. Transformer ni dia tak boleh ikut Ohm's law. Is about VPIP, the input power equals to the output power VS/IS. Kena guna formula tu. Input power VPIP equals to VS/IS. So input power dengan output power is the same. Because kalau ideal transformer lah, it has to dia kata same. Tapi bila VS tinggi, IS ni across the dekat penghantaran ni lah. So IS will be smaller. So bila IS smaller, power loss I squared R. So I squared R tu ialah IS squared times the resistance of the cable. So kita nak power tu yang loss, yang ni, because I squared ni, I is the current yang along the cable ni of the transmission. So kita tak nak I ni besar, kita nak I ni kecil supaya power loss is smaller. So this one tak boleh guna Ohm's law because this one is about transformer. We have to use the input power VPIP equals to VS/IS.
Betul. And kita tahu yang untuk this one voltage inverse with current kan?
Yeah.
Sebab tu you want to increase the voltage so that the current here will reduce. So power loss pun reduce. Okay, so the answer is C. Ingat kan, ni pun sebab ramai student tanya. Kenapa? Diorang confuse yang ini bukan R sama dengan V over I ke? No, that is Ohm's law.
Okay, itu kalau dia tanya, kan soalan yang ditanya kenapa kalau burung tenggek dekat atas cable line ni kan tak mati kan? Because the voltage tu V along the cable ni is small. I buat annotate di sana. Okay. So kalau sinilah V across ni. Now V across ni dia small because the current IS ni is small. Itu kita boleh guna V equals to IR. Kenapa V too small? Because I too small. Resistance pun small because antara kaki burung tu pendek je. So that's why burung tu tak mati because V is small. Because since IS is small, R is small. Tapi bila kita antara voltage yang ini ialah VP IP. Sini ialah VS times dengan along yang ini ialah IS. So ini VS across ni. Yang VP ni across ni. That is VP antara dua ni. Not this V. Ni V lain. Ni V yang ni boleh guna Ohm's law. Ni ialah V equals to IR. V across yang dekat antara wire ni. 2 points in the wire. Sebab itulah kalau kita pegang antara ni dengan ni, kita tak akan cedera. Tapi kalau kita pegang ini dengan cross ni, ini memang hatilah. Helikopter pun meletup lah. Because the voltage across ni is very high.
Okay, saya ada jumpa juga ni. So this one mulakan the explanation.
Mana? Ya, betul. Ni betul.
So the birds pijak sini, so dia tak rasa sebab tak ada potential difference.
Sebab potential difference dia ada, cuma very small. Sebab jarak dia ni pun kecil, dia punya antara dua ni.
So it's
And then
negligible lah.
IS pun kecil. Yes.
Instead of humans, kita kena sebab we are huge, besar.
Sebab kita to the ground. Bila ada ground antara ni memang high voltage lah.
Current flow dia sikit ke? Sikit sebab voltage
Sikit,
dia tinggi.
memang current flow sikit.
Okay.
Tengok ni pun tengok soalan ni nasty ni. Ni banyak ni pengetahuan kena tahu.
Oh, dahsyat ni. Dia buat
sendiri. Dia buat ini je. Current, you must know the direction of current flow. You have to use right hand grip rule. Lepas tu you have to use flaming left hand rule.
Oh,
so what's the answer?
Apa ni? So, first kita boleh determine the ni
First kita kena determine dia punya polarity of this nail. So ini positive, that means awak guna ni, this is atas ni, sini north lah. Sini north.
Kan?
Ya, sini north. Yang ni north kan. Yang bawah ni south. Okay. And then ini pula current kat sini, ini pun atas ni north, bawah south. So kena guna flaming left hand rule. Kita dah tahulah which direction of the magnetic field. So it's upwards. Jadi current positive, so it's current this way. So which is the direction of the motion of the copper rod?
Dapat C.
Flaming left hand rule. Betul? C is correct.
So dapat betul. FBI. So because the current is going out. Kita cakap kreatif juga soalan ni, dia buat sendiri semua.
Oh lah, very creative. I tell you. Bagus soalan dia. I mean, student memang kena tahu banyak knowledge lah. Ni memang
apply two rules.
Tapi soalan macam ni should be asked structure question. Sebab banyak from this diagram you can ask a lot of things.
You can easily
but
do
not objective. Objective dia tak, normally SPM dia tak akan berlapis macam ni.
It's straightforward lah.
Dia straightforward, but then dia ada tricky sikit. Dia kebat lah, memang high order thinking skill lah. But it's straightforward. But you have to use the high order thinking skill. It's not direct.
Okay, baca.
Okay, this one. Ini pun bagus. Soalan ni bagus lah. Maknanya memang berlapis lah.
Soalan ni tak senang lah.
Yeah, it's good because for trial it makes you think.
Okay, which lit with normal brightness?
So normal brightness means each lamp ni kena dapat 12 volt 6 watt. So which one in each lamp will get 12 volt 6 watt? So first you have to find VS for each. You have to find VS for A, VS for B. So VS for A is like 6 volt times 5. Kan? Because NS over NP is 50 over 10. So 5 kali kan? So this one is 30 volt. B, berapa VS dia? 80 divided by 20, 4 times kan? So this one VS dia is 4 times 6, 24 volt. Ini VS dia across dia ialah ni times 2 lah. 100 divided by 50 is 2 times. So 6 times 2, 12 volt. Yang ini tak payahlah, D ni step down dah.
3.
So this is
either B or C
answer. So which one is the correct answer? Which bulb will each get 12 volt, 6 watt?
Mula dia orang jawab C, lepas tu dia orang buat B.
Answer is B, betul? Kalau C, that means each bulb cuma dapat 6 volt because these two bulbs are in series.
Ingat kalau
so C salah lah sebab each bulb cuma dapat 6 volt. Tapi kalau B, each bulb will get 12 volt. So the bulb are in series. Betul?
So the answer is B. Ingat
It's B.
kalau current, terbalik. Current kalau series constant. Parallel plus 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 plus. Dia is opposite. Kalau voltmeter, voltage. Kalau series plus plus plus. Parallel dia same.
Sama.
Kena ingat lah. Kalau resistance pun sama. R, series plus plus plus. Kalau parallel jadi 1/R tambah 1/R tambah 1/R lah. Kita kena ingat lah. Okay, masuk pasal apa ni? Transmission. Dia tanya satu lagi Kak Liza. Kalau power, power pun plus 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 ke sama?
Ya, power series ke parallel ke you plus plus.
Okay, so power irregardless series
regardless of series or parallel, you campurkan.
Always plus. Okay, alright. 44. Pasal CRO dah.
Ni knowledge je.
Senang je lah.
Okay, senang je kan.
Apa jawapan korang?
Question. Buat tak eksperimen ni? CRO ni?
Buat. Masa PKP buat. Masa outreach pun buat.
Okay, good. So they should know lah answer. What's the answer?
Buat.
Oh, Atika buat. Okay.
Benar. Thermionic emission tuan jawab.
Right. Okay, ni senang je lah. Soalan hadiah
lah,
tu senang.
45 pun just a reading question.
So Hamni, this is the, ni semua because there are the 5 electrons. So 5 electrons they are called what are they called? Pentavalent, isn't it? Yeah. So which one yang ni pun macam kena tahu lah, kena ingat lah pentavalent apa dia? Apa kan?
Apa?
APA.
Arsenik. Apa lagi yang lain? Yes. Arsenik, phosphorus, antimony.
Antimony.
Kalau
P-type, BIG. Boron, indium, gallium.
Okay, right. Senang je lah.
Yeah.
Okay, 46.
Okay, this one pun senang. 46.
Transistor.
Ni buat tak eksperimen?
Buat. Masa
demonstration. Outreach.
Ada. Ni si Adam Pat buat.
Okay.
Okay, kita tinggal lagi 10 minit. Okay, apa jawapan 46?
Okay, this one senang kan? So what's the answer?
Dia nak menyala waktu malam.
Waktu malam.
So ingat, property of LER, higher resistance during the night.
Ya, gelap.
So jawapannya apa? Diorang kata A.
A, betul. Good. A is correct. Kalau B ni menyala waktu siang.
Ni menyala waktu siang, betul?
Because what we want is this the base voltage. Base voltage ni is antara B dan B dengan P.
Base voltage is bottom part lah kan?
Bawah ni lah.
Okay, so itulah. Yang lain semua benda berepek.
Sini ni semua, this is base voltage. Yang ini yang kita nak dia tinggi. This one, between this B and E. This voltage mesti high. Then barulah IB flow, switch on transistor, barulah IC flow because transistor dah low resistance. Okay? This is IC punya ni lah.
Liza tanya juga, kalau setup circuit B ni, bila je kita pakai? Ada ke application in real life?
Ini kalau garage ke kan? Kalau kita ada garage, so nak ada kena lampu, baru dia terbuka misalnya. Kan automatic garage yang ni lah, yang waktu malam kan. So ada je.
Depends on the use.
Kesesuaian lah.
Tapi jarang, it's very rare lah, betul juga. In most cases, ideally kita nak lampu menyala time malam. So Selalunya setup A lah, jarang
Ni
lah.
untuk ni. Tapi untuk lampu jalan, mentol tu kena tukar dengan relay lah.
Relay sebab higher voltage. Ni kena convert, pasang relay switch lah kat sini kan.
Yep. Okay.
Dia detect lampu apa, lampu kereta ke? Maybe. Okay, logic gate, everyone's favourite. So macam biasalah, awak work out the combination, masukkan dekat boolean ni, dekat the logic.
Ni kena masukkan lah X ni kena tahu kat kaki tu 0011 misalnya.
Then you try lah. Okay, what's the answer?
Kena tulis kat sini. Lepas tu sini awak kena tulis apa ni? 0101. Kan, habis tu sini pun dan tu kena tukar lah, tukar kat sini 1100.
Ni OR gate.
So write down everything yang dekat kaki-kaki dia ni. Then you get the answer. So the answer should be
apa depannya?
So ini
cakap tak dapat bola.
betul.
Kisahlah nanti masalah. It's not that hard pun boleh buat ni.
Boleh buat logic gate. Ini pun senang.
Ini pun lagilah senang.
Ini senang.
What is the number of neutron? Kata B juga, B.
Okay, betul. 226 minus 88.
Senang Awak dah belajar kat chemistry kan, nucleon number,
neutron's number, ni proton number. Okay, 49. Ini apa jawapan dia? Ini ada background reading. So you have to, the real reading of the GM, the initial kan dia tulis 160 counts. But the actual reading, the true reading, you kena buat 160 minus 40. So that's the actual reading. And then yang 55 after 6 hours ni bukan 55. 55 minus 40. So that means initial is 120. Yang final ialah 55 minus 15. Then you can guna, Afiq ajar tak the formula? N, the N equals to N naught initial divide by 2 to the power of N. Ada tak ajar formula tu?
Tak, saya kena tulis.
Okay.
So
N yang tinggal equals to N naught tu initial, N naught tu divide by 2 to the power of small n. Nombor 2.
Half life.
2 kuasa n. Okay. So n is the number of a half life. Yep. So n ni kita letak 15. Okay. And naught ni kita letak 120. Divide by 2 kuasa n kan? Okay, so kita dapat 2 kuasa n is equals to 120 over 15 lah. So we got 8. 2 to the power n equals to 120 divided by 15 which is 8. Okay, so 8 is 2 to the power of 3. So that means 3 half lives. So ada 3 half life, that means 6 hours divided by 3 kita dapat 2 hours. So I find this formula ni very useful.
N sama dengan N naught over 2
so
to the power n.
formula ni very useful.
Nombor tadi dia asal nombor apa ya? So ingat maknanya 40 ni is background noise lah. So kita kena cancelkan dia.
Cancel.
Lepas tu kita kena tolak. Sebab kita kena tolak sebab tak ada apa-apa pun. Kita tak buat eksperimen dah ada 40. Maknanya
Dah ada dah 40 counts ni.
This is noise. Kita tak nak ni. Kita nak the value of the reaction which is the net lah kena tolak. Okay lah, boleh sebenarnya ni.
Kena tolak background. Ni soalan dalam latihan ada ni. Soalan ni exactly the same.
Banyak dalam modul.
Ada dalam modul.
Okay, last one. Macam systematic error ke, betul? Boleh lah.
Okay lah. Yes.
Okay, yang ni sebenarnya balance equation.
Senang je. Ini campur tolak je. So total belah kiri 236. So yang ini P plus 92 plus 3 times 1. So 95. That means 236 minus 95. Dapatlah P. Yang ni bawah ni 92. Yang belah kanan ni after reaction 56 plus Q plus 0. So 92 minus 56. So this is easy. Plus 0. Not Q, 0. Plus Q plus 0, right? Yeah. Atas tu 235 plus 1 equals to P plus plus 3, yes. Sebab 3 times 1.
Dapatlah. Jawapannya A
yes. Jawapan dia C.
Jawapan C. Okay, typo. Alright.
Answer is C.
Okay, senang Sabun.
Okay, itu senang lah.
Okay, alright Kak Liza. Masa pun dah nak habis ni.
Alright, okay. So jumpa lagi.
Cakap thank you semua Kak Liza, Sudi.
Okay, thank you.
Walaupun dah patutnya boleh bersenang renang di rumah. Tapi sanggup spend masa dengan kita. Tu Kak Liza, dia orang komen semua thank you.
Okay, thank you. You're welcome. Okay. Alright, so next time nanti Cik Afiq beritahu lah dia jual ada kelas. Okay.
Nanti kalau dah tak PKP bolehlah Kak Liza datang pula aja. Datang ke school.
InsyaAllah.
Password tak ada. Okay, right. Thank you semua. Thank you Kak Liza.
Thank you.
Thank you Cikgu Syaril juga ada tu.
Cikgu Syaril pun thank you.
Okay. Alright, thank you semua. Have a nice day. See you all.
See you all.
Bye. Assalamualaikum.